Hi, I'm going to speak about some of the topics in discrete mathematics, mainly about permutations and combinations. First, I will explain some fundamental ideas. Probability. It says how likely an event can occur. It has a value between 0 and 1 inclusive. The larger the probability, the more likely an event will occur. It is calculated by dividing desired number of outcomes by total number of outcomes. For example, probability of getting ahead in tossing a fair coin is 1 by 2. Here, the desired number of outcomes is equal to 1. Total number of outcomes is equal to 2, which is head and tail. Probability of getting a number 3 in rolling a fair dice is 1 by 6. Here, the desired number of outcomes is equal to 1. Total number of outcomes is equal to 6, which is number 1 to 6. Likewise, probability of getting an even number is 3 by 6. Next, we can look at sum and product rules. Sum rule. If one event can happen in m ways, and another event can happen in n ways, and these two events cannot happen at same time, then both events can happen in m plus n ways. These events are also known as mutually exclusive events. For example, probability of getting a head or tail in tossing a fair coin is 1 by 2 plus 1 by 2 is equal to 1. Here, one event is getting a head and another event is getting a tail, and both events cannot occur at same time. So we add the probability of both events. Product rule. If one event can occur in m ways and another event can occur in n ways, and two events can occur simultaneously, then two events can occur in m into n ways. These events are also called independent events. For example, probability of getting two heads in tossing two fair coins is 1 by 2 into 1 by 2, that is equal to 1 by 4. Here, the probability of first event is 1 by 2 and the second event is also 1 by 2, and the result is product of both. Factorial. Factorial of a positive integer is the product of all positive integer less than or equal to itself. Example, 5 factorial is product of all integers from 1 to 5, which is 120. Sets. Sets are used to group objects together. A set is an unordered collection of distinct objects called elements or members of the set. Members of the set are listed between the braces. We write A belongs to S to denote that A is an element of set S, and the notation A does not belong to S denotes that A is not an element of set S. For example, set V of all vowels in English alphabets can be written as V is equal to A E I O U. Multiset. Multiset is also a collection of distinct objects similar to set, but it also has multiplicity of each element in the set. For example, let's look at the multiset of characters present in the word mathematics. Here the characters M, A and T have multiplicity 2 and other characters have multiplicity 1. Inclusion and exclusion principle. Let's look at a problem. In a class, 30 students obtained S grade in math subject and 40 students obtained S grade in physics. To count the number of students who obtained S grade in either maths or physics subject, we cannot directly add the count of both groups of students because students who have obtained S grade in both subjects will be counted twice. So we need one more information, the count of students who obtained S grade in both subjects. So the union of two sets can be defined as sum of the number of elements of two sets A and B minus the number of elements in their intersection. If the number of students who obtained S grade in both subjects is 15, then the answer is 55. It can be represented in Venn diagram as this, where left circle represents students who obtained an S grade in maths and right circle represents students who obtained an S grade in physics. We can consider another example containing three sets. How many numbers below 100 are divisible by numbers 2, 3 or 5? Count of numbers divisible by 2 is 49. Count of numbers divisible by 3 is 33. Count of numbers divisible by 5 is 19. Here, we should not double count or triple count numbers. For example, number 10 is divisible by 2 and 5. Number 15 is divisible by 3 and 5. Number 30 is divisible by 2, 3 and 5. So, union of three sets can be defined as sum of the numbers of elements of three sets A, B and C minus intersection of any two sets plus intersection of all three sets. Count of numbers divisible by all three numbers 2, 3 and 5 is 3. Count of numbers divisible by 2 and 3 is 13. Count of numbers divisible by 2 and 5 is 6. Count of numbers divisible by 3 and 5 is 3. So the result is 82. It can be represented in Venn diagram as this, where The top left circle represents the count of numbers divisible by 2. The top right circle represents the count of numbers divisible by 3. And the bottom circle represents the count of numbers divisible by 5. In general, for calculating union of sets, we subtracted the intersection of sets if their cardinality is even, or we added the intersection of sets if their cardinality is odd. Next, we look at combinations and permutations. Many counting problems can be solved by finding the number of ways to arrange a specified number of distinct elements of a set, which is also known as permutation of the set. For example, how many different ways a group of 10 students can be arranged in a line. Many other counting problems can be solved by finding the number of ways to select a particular number of elements from a set of particular size, where the order of elements selected does not matter, which is also known as combination of numbers. For example, how many student committees of size 3 can be formed from a group of 10 students? Permutation can be defined as arrangement of members of a set in a linear order. There are two types of permutations for a set of elements. One type is without restriction, where all elements or specified number of elements of a set are arranged without any restriction. Formulas for finding the count is permutation of all elements of a set with size n is n factorial. Permutation of all elements of a set with size n is p of n comma r, which is n minus r factorial divided by r factorial. For example, arrangement of numbers from 1 to 10 is 10 factorial. Permutation of first, second, and third place won by 10 horses in a race if there is no tie is p of 10 comma 3, which is 7 factorial by 3 factorial. Another type is with restriction. For finding the permutations with restriction, we just have to include the arrangements that satisfy the restriction. For example, anagrams of the word income such that COM should be consecutive characters is 3 factorial into 3 factorial. First 3 factorial is for permutation of consecutive characters COM, and another 3 factorial is for permutation of other characters. Note that no characters is repeated in this word. If there is no restriction, the total number of anagrams of the word is 6 factorial, but the answer for this problem is 36. There are two types of permutations for a multiset of elements or collection of elements where replacements are allowed. One type is without restriction. There are some problems which involve finding permutation of collection of elements which are not distinct. Formulas for finding the count is: if there is a collection of elements where there are A count of elements of one type, B count of elements of another type, and C count of elements of another type, and total count of elements of collection is n is equal to A plus B plus C, then its permutation is n factorial by A factorial into B factorial into C factorial. If the set has n elements, then the number of permutations with size k is n power k. For example, anagrams of the word Mississippi is 11 factorial by 1 factorial into 4 factorial into 4 factorial into 2 factorial. Here, character M is repeated once, character S and I repeated 4 times, character P is repeated 2 times. Permutations of 4-digit binary numbers are 2 power 4, where 2 is the size of the set 1, 0 and 4 is the size of each arrangement. Another type is with restriction. As already stated, for finding the permutation with restriction, we just have to include the arrangements that satisfy the restriction. For example, to count all 5 character words with at least one lowercase, one uppercase, and one number from the character set which contains all lowercase, all uppercase, all numbers. First, we calculate the number of words that can be formed without lowercase characters, number of words that can be formed without uppercase characters, and number of words that can be formed without numbers. Finally, we subtract all these numbers from the total number of words that can be formed with this character set. There is one more type of permutation, which is circular permutation. There is no starting element in circular permutations opposed to linear ordering. Two circular permutations are considered to be the same if one can be rotated into another. There are n minus 1 factorial circular permutations. To calculate the number of arrangements, we arbitrarily fix one element and permute other elements. For example, in a dinner table, 11 members are to be seated. In how many ways can they be seated? It is 11 minus 1 factorial. Problems can have restrictions in finding the circular permutations. For example, in the same problem, out of 11 members, There are 6 men and 5 women. In how many ways can they be seated if men and women alternate? It is 6 minus 1 factorial into 5 factorial. Combinations can be defined as selection of items from the set such that order does not matter, unlike permutation. There are two types of combinations for a set. One type is without restriction, where a specified number of elements of a set are selected without any restriction. Formula is C of n comma k is equal to n factorial by n minus k factorial into k factorial. For example, choosing any numbers less than or equal to 5 without replacement is C of 5 comma 3. Another type is with restriction, for which we just have to include selections that satisfy restrictions. For example, choosing any three numbers less than or equal to 10 such that three numbers should not have the same parity is C of 10, 3 minus C of 5, 3 minus C of 5, 3, where the first C of 5, 3 is for all three even numbers and the second C of 5, 3 is for all three odd numbers. There are two types of combinations of a multiset or collection of elements where replacements are allowed. One type is without restriction. Formula to find combinations of elements where replacement is allowed is C of n plus r minus 1, comma r. For example, choosing any three numbers less than or equal to 5 with replacement is C of 5 plus 3 minus 1, comma 3. Another type is with restriction, where we just have to include the combinations that satisfy the restriction. For example, choosing any three numbers less than or equal to 10 with replacement such that three numbers should not have the same parity is C of 10 plus 3 minus 1 comma 3 minus C of 5 plus 3 minus 1 comma 3 minus C of 5 plus 3 minus 1 comma 3. Now we can see how permutations and combinations are related. Since in combinations order of the elements does not matter, we can say C of n comma k is equal to P of n comma k by P of k comma k, where P of k comma k is the ordering of k elements. Let's see some more examples. A couple decides to have 4 children. If they succeed in having 4 children and each child is equally likely to be a boy or a girl, what is the probability that they will have exactly 2 girls and 2 boys? Answer is 4 factorial divided by 2 factorial into 2 factorial. Second example, Mary and Joe are to throw 3 dice each. The score is the sum of points on all 3 dice. If Mary scores 10 in her attempt, what is the probability that Joe will outscore Mary in his? Let's count the number of values in each range. 3 to 10 is 8 values, 11 to 18 is also 8 values. So, probability of getting each range is 1 by 2. So, the answer is 1 by 2. Third example, 2 dice are rolled once. The probability of getting an even number at the first die or a total of 8 is, it can be calculated as P of A union B is equal to P of A plus P of B minus P of A intersection B. Here, P of A is equal to 1 by 2, P of B is equal to 5 by 36, and P of A intersection B is 3 by 36. So the answer is 20 by 36. Fourth example. Kate and David each start with $10. They flip a coin 5 times. For each flip that results in heads, Kate gives David $1. And for each flip that results in tails, David gives Kate $1. After flipping the coin for 5 times, what is the probability that Kate has more than $10 but less than $15? There are two scenarios where Kate can get more than $10 but less than $15. That is, 4 tails and 1 head or 3 tails and 2 head. So the answer is permutation of these two scenarios, that is divided by total number of permutations, that is 32, which results in 15 by 32. Thanks. If you find this video valuable, you may share with others. If there are mistakes, please mention them in the comment section.